All right, so in the table, find as many patterns as you can. Use one or more patterns to help you complete the table. Be prepared to explain your reasoning. Okay, so what am I going to put right here? Actually, first of all, what's the pattern that you notice? Notice a pattern? We go from 0.5 to 0.25. Let me try to make this a little bit easier. I go from 50 to 25. What did I do? How did I go from 50 to 25? Subtract 25, or what's another way to say that? Use another operation. We're not going to multiply. We're going to divide by 2, right? If I take 25 and I divide by 2, then that's going to be 12.5. If I take 12.5 and I divide by 2, what am I going to get? 0.0625. If I take if I take 0.0625 and I divide it by 2, I'm going to get 0.03125. You see the pattern? Okay. Also, in our fractions, we're multiplying by 2. So when we put it in decimal form, we're dividing by 2. Okay, so today we're going to revisit writing and evaluating exponential interest problem. So you saw this back in the day when you were in Algebra 1. Okay, we got a marine biologist estimates that a structure of coral has a volume of 1,200 cubic centimeters and that its volume doubles each year. Create a table to find the volume of the coral when T is 0, 1, and 5. Okay, so here's our table. T is going to be 0, 1, and 5. Okay, so what is our starting amount from this little sentence that they give us? Our starting amount. 1,200, right? Now, if we're going to double each year, what is double of 1,200? 14. What's 12 times 2? 2,400, right? Okay, but now we want to get to year 5. Okay, so we could sit here and we could multiply by 2, right? Or could we create an equation? I like equations just because that makes my life a little bit easier. So you told me that the initial amount is 1,200, right? And then we're saying that it doubles each year. So that's going to be our rate. Now we can take this equation and substitute in a 5. And that'll tell us how much or how big the coral reef is, right? So we're going to take 2 and raise it to the 5th power. And that would give us 32. And then we're going to multiply it by 1,200. And so that's going to give us 38,400. Now, remember when I said that you can't have negative numbers? Good morning, the introduction. All right, so now consider when T is -1 and T is -2. So remember when I told you can't have negative time? Think about it like this. This equation is starting at a point in time, and we're trying to look backwards. So this problem does deal with a little bit of negative numbers. In normal instances, you won't have negative numbers. However, if I was trying to find when T is -1 and T is -2, how would I go about doing that? I'd start at 1,200, and we know that -1 is 1 backwards, right? So what would I do to 1,200? Okay, so this way we multiplied by 2, right? What are we going to do going backwards? There we go. Okay, divide by 2 for that 1,200. What's 1,200 divided by 2? 600. Now we're going to go back one more time. So what are we going to do? Divide by 2. What's 600 divided by 2? 300. Okay? Does that make sense? T is time. Yep. And time is always going to be like what they're talking about normally. So if you ever see T, just assume it's time right then. I just work here. Okay. So let's talk about this. Write an equation of the form y equals a times b raised to the t, representing the relationship where time is in years since the coral was measured and y is the volume. We just did this. We actually did this on the previous page. I jumped ahead. So y is going to equal, what was our initial amount for that coral? What was that initial amount? 1,200. Okay, and then how much were we going up by each year? Going in the positive direction. We were going up by 2 because it said doubles, right? Voila. Okay, in a certain year, the volume of the coral is 37.5 cubic centimeters. Which year is this? Explain your reasoning. Yikes. So how would we go about solving this guy? They give us a volume and they tell us which year. So what are we solving for? Are we solving for y or are we solving for x/t? What was it? Okay, so we're solving for x or t if you want to do it that way too. So we're going to plug in 37.5 into our equation. Okay. Now, how do we get x by itself? What's the first thing we're going to do? Well, we see that these two things are multiplied. So I'm going to divide by 1,200 on both sides. And when I do that, that's going to give me 0.03125 equals 2 raised to the x. Okay. Well, let me ask you this question. 2 raised to what power would give me 0.03215? Yeah, I don't know that off the top of my head either. I know it's going to be a negative number though, right? Yeah. The reason why I know that is because it's a decimal. Okay. All right. I'm going to show you something a little ahead of time. It's called the circle of life. Yes. Just like the movie in Lion King. It's fine. Okay. So what you're going to do is if you have something written like this, okay, you have y equals base raised to the x. In order to convert this into log, you are going to start at your base, go to the outside, and finish at your exponent. Yeah. Okay, so the way I'm going to write this is I'm going to say log of base y equals x. Okay, so what's going to happen is you're going to start at your base, go to the outside, finish at your exponent. So I'm going to write this out as log of base 2 of 0.03125 equals x. Fortunately, Desmos does all of the work for you. So once you get to this spot, we're just going to type it straight into Desmos. And I'm going to show you how to do that in just a second. Okay, so I'm going to show you how to type this into Desmos. So when you go into here, you're going to find the function. I always forget where this one is. This log of A. Okay, so it's underneath the one that says calculus. Obviously, no, we're not doing calculus. Okay, but you're going to say log of base 2 of 0.03125. And that gives me -5, right? So my final answer is going to be x equals -5. So x is going to equal -5. That means 5 years before, we're going to have a coral reef that's the size of 37.5. Okay. You could also use that table that we had from the beginning. So looking back at this table over here, kind of reminding you of where we were at. We had 0.0625, and then we have 0.03125. This is what we were looking for when we were solving, right? Well, 2 to what power would give us 1/32? Well, that would be 2 to the -5th power. So that's where that -5 comes from. Okay. Another way you could have gone about solving this one is if you went into Desmos and you typed the equation out that we had. So we had 2 raised to the x power. Okay, and then you could look at the table and you could see where you get your number. So you would type in like -3, -4, -5, and we see that 37.5 is right there. Again, that's without having to solve all of this. Okay, I want you to take a moment. I want you to read this one over. See if you can write the equation for this one. Take a second, see if you can write the equation for this one. Okay, so how would I write this equation? What's my initial amount on this one? 1,000. And then what's my rate? Okay. And we got that raised to the t power. And they tell us that we want to write an equation for the value of p. So we're just going to put p out front. Now, this is asking us after 2 years, how much is the phone worth? So what we're going to do is we're going to plug 2 in for t. And then we're going to go into Desmos and type that in. So what is that going to give me? 360. Okay. So after 2 years, you started off with a $1,000 phone. After 2 years, it went down to $360. Like, that's some messed up stuff, right? Okay, so it says a group of biologists is surveying the mice population in a forest. Here's the equation. It gives a total number of mice in T years since the survey began. So what does the number 75 represent? I heard it. Initial population of the mice, right? And then what does the 3 represent? So we got an initial population and then how much they're going up by, right? So this is the rate at which the mice are going up. Okay, so Janet took some medicine 3 hours ago, but does not remember how much. Concerned that she took too much, she has a blood test every hour for several hours. Time T is measured in hours since the blood test, and the amount of medicine in her body, M, is measured in milligrams. So what is the growth factor, also known as B, in an equation form? And then what is the A? Okay, so how do we figure out what the A is? Let's start there. It's 100. Okay, so that's going to be our y-intercept, right? Okay, B is going to be our rate. So it's going from one number to the next. So we went from 100 to 50. So what do we do here? Divided by 2. The way we write that out in fraction form is we say 1/2, right? One thing I want to make you pay attention to is this word, well, these 2 words, growth factor. This is going to be different from words like growth rate. And we're going to see that later. Okay, pay special attention to growth factor. If it says growth rate, they're asking for something different. All right, so now we got to figure out how much medicine Janet took, right? Okay, so how much did she took? Well, Janet took the medicine 3 hours ago, right? And we started at time 0. So how do we figure out how much she had in her system 3 hours ago? You plug it into the equation. What are we going to plug in, though? We want to figure out 3 hours ago, right? -3. Okay, so we're going to plug in -3 into our equation. We're going to say 100 times 1/2 raised to the -3. Okay, so when we do that, that's going to give us how much? Well, we're going to plug in a Desmos. So 100 times 1/2 raised to the -3rd power. That's going to give us 800. Okay, so she took 800 milligrams of whatever medicine she was supposed to take, right? All right, so you need to pay an 8% tax on a car that costs $1,200. What will you end up paying in total? Show your reasoning. Okay, so you know how you like go to the store and you're like, okay, I'm gonna buy this, this, and this, and it's like $10, but then you got that sales tax. It sucks, right? Anyways, but same thing happens when you buy cars. There's a lot of different things that go into it, but how would you calculate your total cost? It's not just going to be $1,200, right? How do I calculate sales tax? Or how do I calculate tax? Okay, so we're going to take 12,000, and we're going to multiply by what? Not 8, but we're going to multiply by that 0.08, right? Okay, so that's going to tell me how much tax I'm going to have on this car. So I take 12,000 and I multiply by 0.08, and that's going to be $960. So this is just the tax that you're going to pay on the car. how much am I going to pay in total? Well, I'm going to take the total of the car plus the sales tax or whatever tax it is. And that's going to give me $12,960. Yep. All right, so burritos are on sale for 30% off. By the way, if burritos are on sale for 30% off, check the expiration date, right? No, just me. Okay, thanks, guys. Your favorite burrito normally costs $8.50. How much does it cost now? Show your reasoning. Okay, so how am I going to go about solving this? Okay, spin the 30% to 0.3. Multiply it times 8.50, right? Okay, so we get 8.50 times 0.3, and that gives me $2.55. Is that how much it costs now? Okay, so what do we need to do now? Well, we're getting a discount. Wouldn't adding that make it more, right? What are we going to do instead? Subtract. So we're going to take 850 and subtract that 2.55, right? Okay, so we get 850, subtract 2.55. That's going to give us $5.95. I'm going to show you an easier way to do this. Coming back up here to the top, if I took 12,000 and I multiplied it by 1.08, 12,000 multiplied by 1.08, that automatically gives me 12,960, which is what our answer was, right? And I didn't have to do all this adding and subtracting. On this second one, if I take 850 and I do 1 minus 0.3, that gives me $5.95. So when we're adding something, we're going to have 1 point, whatever the discount is, or I'm sorry, whatever the plus is. If we're having a discount, we're going to have 1 minus whatever the percentage is. And we're actually going to see that in this next part. Here's some familiar formulas. Okay, you probably saw these back in Algebra 1, or you probably saw them back in like 8th grade. Okay, so you got simple interest, which is what we were just finding. You got compound interest, which is dealing with all your money. And then you got exponential growth, which is also dealing with money. Okay, so just kind of revisiting that. So simple interest. With these problems, it's a lot of reading. So you got to pay attention to what is the question asking. So this says, in the last 12 years, an initial population of 38 buffalo in a state park grew by about 7% per year. Write an equation modeling the situation. So they said that we're going to use simple interest, right? So we're going to use the formula from the previous page. A equals P times 1 plus or minus R raised to the T. So I'm going to go ahead and copy that down. A equals P times 1 plus or minus R raised to the T. What? Yep, go ahead. Okay, so how am I going to write the equation for this one? Well, what's the initial amount? What's my initial amount? It's the fact that I'm circling it. Y'all ain't answering me. 38 would be our initial amount. So that's going to be our p-value. And what's the rate that they're increasing by? 7%. So we're going to say 1, and they're growing, right? So we're going to say plus 0.07 and we're going to raise it to the t power. The next question asks, how many buffalo are there going to be in 8 years? So what are we going to do to this equation? Well, we're going to take it and we're going to plug in 8, right? So we're going to go into Desmos. We're going to type that in. And so that's going to give us 65.29. Can we have half a buffalo? I mean, I guess if you're like at a restaurant, right? But in this case, no, we cannot have half a buffalo. So we're going to say there was 65. Some answer choices might say 66, but whichever one they give you as an option that's close to that. Right, let's take a look at it. It says in 1990, the population of Austin, Texas was about 596,297. During the next 10 years, the population decreased by about 3.1% per year. Okay, so what's my initial population right now? 596,297. Okay, is this increasing or decreasing? Decreasing. So we're going to say 1 minus, and what is our rate in decimal form? 0.031, right? We move that decimal place over 2 times. It's going to be 0.031, and we're going to raise it to the t power. Now, it asks us to put, what was the population in 2015? Are we going to put 2015 in for t? No. Okay, so we started in 1990, and we're going to 2015. How many years? 25. So we're going to plug in 25 into our equation. Okay, when we plug in 25, we're going to go into Desmos. We're going to type it in. Good morning. Drop right there. Thank you. Okay, and we're going to get 271,367, and it says 0.01. Well, we can't have half a person, so we're just going to leave it as 271,000. Say again? Okay. Again, this is probably something familiar. You're going to use the equation that says compound interest. So looking at it, here's our compound interest formula. I'm going to go ahead and write that down. Okay. So you deposit $1,000 in an account that pays 4.75% interest compounded quarterly. What will the balance be in 5 years? Okay, so P is always our initial amount, right? So what is our initial amount that we deposit? 2,000. Okay, what's our rate gonna be in decimal form? Not percentage form, decimal form. Well, that's gonna be 0.0475 because we moved that decimal place over twice. I'm gonna go ahead and plug that in. And N represents how often that happens. What does the word quarterly mean? How many quarters are in a dollar? 4. So it happens how many times in a year? 4 times in a year. And we're going to plug 4 in for that in up here as well. And then how many years are they looking for? 5. So we're going to multiply that by 5. You're going to type all this mess into Desmos. Okay, so we're going to type that into Desmos. Okay, 2,000 times 1 plus 0.0475 divided by 4. And the biggest thing is you got to be careful with your parentheses. If you don't use them, you lose them. And that's going to give me $2,532.60. $2,532.60. Remember, money is always rounded to 2 decimal places. That's it. Can you try this next one? Can you see if you can set it up? Okay, so we got initial amount is $2,000. Okay, and then we're going to change that rate to 0.0375. Now they say monthly. How many months are there in a year? 12. So we're going to put 12 in for in, and they're wanting us to do it over 5 years, right? So we're going to take this mess and we're going to type it into Desmos. So 2,000 times 1 plus 0.0375. We're dividing it by 12. And we're going to raise it to 12 times 5. And that's going to give us $2,411.76. Okay. Oops. Okay. So looking at this is the important part, because each bank is a little different. I'm trying to give you good advice. Each bank is different. The interest rate is different for each bank. Okay, now Jermaine's told you. Okay. And then on top of that, you have to look at how often it's compounded. Okay. So if it's frequently compounded, that's a good thing. So like this one has a lower interest rate, but it's compounded more. This one has a higher interest rate, but this is compounded only 4 times a year. Okay. So you really have to pay attention to your bank and what they're saying and what their interest is, and compare banks. Don't just put your money wherever. Okay, that's my little spiel. Okay, compounded continuously. So looking at the equation for this one, compounded continuously, this is PERT. P-E-R-T. P-E-R-T. And we just learned about the E, right? How much is E? We learned this yesterday, the day before. What does E represent? What number? Well, if we forget, what can we do? Go into Desmos and type E in and raise it to the first power. So how much is E? 2.718. Okay, so what we're going to do is we're going to plug this information into this equation. So it says you deposit $3,500. Well, $3,500 is going to be our initial. E is going to be our base. Our rate is 4%, so we're going to change that to a decimal. So that's going to be 0.04, and it wants it after 1 year. So we're going to multiply it times 1. Okay, so we're going to go ahead and plug all of that in. We got 3,500 E raised to the 0.04 times 1. What's up? No, we're almost done. All right, we're almost done. We're almost done. We're almost done. Okay. Can you try this next one? What you're telling me is that you should get 100 on this section because it's so easy. In, then you're going to get $5,833.49. Okay, again, this stuff should be pretty easy. All you're doing is plugging in. You read the problem, you take the information, plug in. Please don't mess up these problems. Okay. The biggest things that you need to pay attention to are the adverbs. Y'all know what adverbs are? Yeah, language arts. Throwback. Yeah, we know what adverbs are. Okay, so that's anything that ends in that ly normally. Okay, so like quarterly, monthly, continuously. If they say continuously, you're going to use the E one, the per. If they say quarterly or monthly, that's going to be something like the compound interest. If they're just talking about population, you're going to use simple interest. Okay, so you got to know when to use which one. Okay, so looking at this guy, looking at this one, it says a colony of insects is 9,000 when it was first being studied. Here are the two functions that can be used to model the growth of the colony after the study begins. Which type of scenario would you use? The first one, and which type of scenario would you use the second one? Okay, so remember, anything that looks like this is compounded continuously, right? So we're talking about this colony of insects, right? So this one would be used if it was continuously growing. This one would be used if it's growing consistently. So like every year, it's getting bigger by 2%. Okay, you got to know the difference between the two equations.